an adversary in all of this, right? And what it can do. And second is that I'll try to introduce reinforcement learning a little bit, although it comes much later as per the course handout. But so whenever we are talking about game playing, we have to talk in terms of reinforcement learning, right? As I told you, all these solutions that have been there, like for AlphaGo, right? Or sorry, for the Go game, right? So there was a solution that was first proposed was AlphaGo, and then the next solution that was given was AlphaGo 0, right? So basically 0 stands for that they did not train any system. So they learned everything as the game unfolded, right? So this was a major breakthrough again. So I have a paper, I mean, there is a paper on AlphaGo 0 as well. So I'll also upload this, right? And this has something to do with reinforcement learning. All right. So I'll be touching upon these topics today. And let me also tell you that I'll be giving you one assignment, right? Okay. So one assignment which will be based on concepts related to reinforcement learning. So from that angle also, I wanted to talk about reinforcement learning early in the course. All right. So now let me take you back to the presentation. Just figure out how this to be done. Okay, blank screen. So now let me introduce another blank screen. Okay. So now, how many of you know about thresholding functions? Okay, thresholding functions means it's a concept of putting a threshold. So you have, say, two types of points. Okay, so one is a plus and the other are minus, right? Okay, and you need to find a threshold in such a way that, suppose this is the number line, right, a real line, and you are given some points and you have to find a threshold which is typically indicated by a theta, right? And on this side there are positive points and on the left there will be negative points. So you have to find this threshold function. All right. Okay. So now if I talk about thresholding functions, so I'm introducing this in the context of an adversary. So I'm trying to introduce an adversary. Okay. Right. So suppose you have just 1 point. Okay. So all of you are able to follow what I'm talking about. So I'm trying to introduce the concept of an adversary, right? Which is the fundamental concept behind adversarial search, right? So I'll introduce it through a very simple function called as thresholding function, right? And I'll discuss different aspects of this, right? So that you understand what an adversary will be doing, right? Or what is the role of an adversary. Second thing I'll be doing today is talk about reinforcement learning, right? So I'll introduce that. So these are the two things that are on the agenda today. So suppose you have just 1 point. Okay, so if I take this number line again, and you take a point, so let me, I don't know if I can change colors. Okay, so let me see which color would work. Okay, so I'll use a green, and probably I can use, okay, so 1 point. So I'm discussing 1 point. So suppose there's just 1 point. Okay, okay, so so the adversary, the role of the adversary is that it can label this point. So there are two labels, plus or minus. Okay, so suppose the adversary labels this as a plus. Okay, so where would you put the threshold? Theta. Yeah. On which, say, where means on which side of this point you would put the threshold. Yes, any answers? Yes, anyone? I'll not be able to check the chat, so please speak up whenever you have anything to ask. Okay, so on which side? Let me just no, not like this. Okay, so fine. So if my point is this, the green cross, and the adversary, right, labels it as plus. So where should I have my threshold? On the left of this or onto the right of this? Yes? Have you understood the problem? Hello? Yes, you guys have to speak up, otherwise I would not know even that you are able to hear me. Hello? Maybe something wrong with the settings, I really don't know. Oh, okay. Yes, are you guys able to hear me?
Sir, didn't get the question properly.
You're not, are you able to see the screen? This screen?
Yes, sir.
Where I'm talking about thresholding functions? Yeah, can you see the screen?
Yes, sir.
Okay, so what I was trying to introduce was the concept of an adversary or the role of an adversary. So for that, I'm taking a very simple kind of a function, which we call as the thresholding function. All right. And so what is the role of thresholding function? Say, suppose you are given two types of points. One is a plus, or two types of labels, right? One is a plus and one is a negative. So the role of the thresholding function should be such that the points to the right are all pluses and points to the left are all minuses, right? And if I am on the real line, so you understand the order in which points would be there, right? Now suppose I'm talking about just one point, okay? And the adversary, wherever that point is, right? The adversary can label it in any way it likes, right? So it can label it as a plus or it can label it as a minus. Okay? Okay? So what if my point is here, right, as shown in this on this real line, right? So where would be my theta? Theta is the threshold. To the left of this point or to the right of this point? It should be on the left. Say, suppose I put it here. Right. Now, I draw the real line again, and my point is here. And suppose the adversary labels it as a negative. Right? Because the adversary is free to label the points in any way it likes. Right? That is the role of the adversary. Okay? So, where should should my theta be? Now, in context of the new labeling that the adversary has given, so where should be my theta? Theta should be on the left or onto the right? It should be on the right side. Anywhere on the right side is theta, right? So what I'm saying is that if I'm just having one point, right, and irrespective of what the adversary, how the adversary labels it, I'm able to figure out this theta. All right? Is that okay? Right? So any point you give and any label you give to that point, I'll be able to find a theta. All of you agree to that? All of you understand that?
Yes, sir.
Okay. So now let me do something different. Okay. So now I take the case of 2 points. Okay. Again, my objective is to learn theta, right? So now let me draw this 2 points. So, okay. So one is this and the other is this. So these are the 2 points, right? Okay. And now, so first of all, so there are 2 labels and there are 2 points. So how many possible labelings? How many possible labelings? 4. That is 2 raised to power 2. In the previous case, when there was just 1 point, how many labels? 2 labelings, right? Okay, so now we have 4 labels. Okay, okay. So this is for the single point, 1 point, and here this is for 2 points. All right. So let me draw all the possible 4. So okay. So the points would remain the same, right? I'm not going to change the position of the points. So now adversary comes, okay? And let me use a different color pen so that you are able to. All right. Oops. Yeah. Oh, I lost that. Oh God. Okay. So let me quickly draw that. Sorry. Three and 4. So let me. Okay. So now 4 possibilities, and now adversary comes and it labels both the points as negative. Okay, it can do that because adversary is free to label the points in any way it likes. Now, can you learn the threshold function? Yeah. So where should be my threshold function? Yes, any idea? Okay, so let me give you some options. Should it be in between the 2 points? Should it be to the left of both the points or to the right of both the points?
To the right.
To the right? Okay. So can I put it here? Is it okay?
Yes, sir.
Okay. So now let me take another case. Just a minute. Green. Okay. So now in the second case, the adversary labels both these points as pluses. So this is case 1. This is case 2. This is case 3. And this is case 4. Right. So now the adversary comes and labels both the points as pluses. Yeah, now what happens? Where should be my theta? So again, I give you 3 options: in between the 2 points, on the right of 2 points, or on the left of 2 points that are shown. Yeah. Hello.
To the left.
To the left. So I draw my theta here. Right. Now let us come to the third case. And what the adversary does is that it draws a plus here. I mean, it labels this point on the right as plus and the point on the left as minus. So now, where should be my theta? Yes,
In the middle.
in the middle. All right. So this should be my theta. Now, there is another possibility, right? Okay. The fourth case. So what could be the fourth case? So can you help me how the adversary, I mean, it is the one case that you have not discussed so far. So what will the adversary, how will the adversary label the fourth case? The right point, it will label as, yes, it will label it as a negative. And the left point, it will label as plus. All right. Are you getting this? So now, in this fourth case, where would you put your theta or the thresholding function? We cannot put, right? So that is correct. So we cannot do this. Okay. So the main thing here is that adversary will try to make the main concept that you need to take away from here is that the adversary can put you in a situation where there is no solution. Okay, and this particular case illustrates that, right? So wherever you put theta, you are not able to say that the points to the right are all positive and points to the left are all negative. All right. Okay. So now, if I give you say 3 points, okay, all right. So any 3 points, okay. So let me add a point here, right? Just okay. All right. So how many cases now? How many possible cases? When you have 3 points, 8, right? So you can enumerate all 8 of them, right? And let me give you some simple solutions, simple cases. One is this, when all are negative. One is this, when all are positive, right? Okay. So out of these 8 cases, whenever there is a negative label to the right of the positive label, you will not be able to find a solution, right? So when I had just 1 point which needed to be labeled, I could find a threshold function for all cases, right? All the possible 2 cases. When there were 2 points, I was not able to find a solution, right? Okay, and same thing is true with 3 cases or 3 points. All right, all right. So it is easy to see that anything beyond 1 point, you are not able to find the threshold function. Is that okay? Right? So this is a concept, I mean, which I'll not try to introduce at this point, but this is something called as shattering. So how many points a threshold function or a family of threshold functions can shatter? So you can see that it can shatter only 1 point. If there are more than 1 points, then it is not able to shatter the points. All right. So have you understood this concept? Have you understood the role of an adversary? So the adversary will try to make your life difficult, right? And often it puts you in a situation, right, where you don't have a solution. Like in this case, in the case of 2 points we saw, in the case of 3 points also we saw. So suppose in this, so if this is the case, right, so you'll not be able to find a theta. All right. So the role of an adversary is clear to all of you. All right. So I'm assuming that you have understood the role of an adversary. So I'm removing this slide now, and I'm taking you to another aspect. So 1 point. So this is what I was discussing with you, right? Okay. So 2 labelings, right? So you can see here. So there are 2 labels. Number of points is here, and the number of classes is here. Number of different labels, right? So 2 points that we also discuss, right? Okay. So this we also discuss. So draw the 4th case, which we have done already now, right? All right. So fine. Now, I would like to introduce 2 more. So this I'll give you as an exercise, right? Okay. So what we discussed just now was a thresholding function. So I'll tell you something about this so that you can use it in different perspectives. So it is basically a thresholding function is a classifier. Classifier in the sense that there is a rule that anything greater than theta, any value greater than theta is positive, and any value less than theta is negative. So you are able to use this function to classify points into 2 different categories. One is plus and one is minus, right? So it is also called as in machine learning and in data mining, it is also called as a decision stump. Okay, and it is the simplest form of a very important class of algorithms, which is called as a decision tree. Right, so you keep these things in mind, so you will find them, like you will learn about them, probably not in this course, but in some other course, right? But in the decision trees, you will come across. We have been working with trees all through, right? So just keep these things in mind, right? So this thresholding function is a kind of a classifier, and this is your classification rule for this, right? And again, we are talking about only 2 types of classes. One is positive, one is negative. Now I'm going to introduce an interval classifier. All right. So what do we mean by an interval classifier? So again, you are on the real line, like you are shown here, right? So this classifier is defined in such a way that it defines an interval, right? AB. Okay, so if this point is say A and this point is say B, so the classification criteria is somewhat like this, that if X belongs to the closed interval AB, it is a positive point, and if X does not belong to AB, it is a negative point. All right, so this is my classification criteria in case of an interval classifier. Okay, so right, and then we have what are called as box classifiers, right? So box classifiers you can see here. So what it does is that, so there is a box, right? Okay, and all the points inside the box are positive and all the points outside the box are negative. So now you can see that we have moved from a 1-dimensional setting to a 2-dimensional setting, and this can be generalized to any number of dimensions, because the concept of box can be applied to 3 dimensions. It can apply to n-dimensional spaces and all of that, right? So now if I give you a box classifier, and for simplicity, let me keep it at 2 dimensions. All right. So now tell me, I mean, your exercise for today is that how many points, right, this interval classify can shatter. All right. And similarly, you have to tell me how many points a box classifier can shatter. All right. So have you understood the problem, first of all, what you have to do? Okay, so let me give you some idea so that you can work on this on your own. And this is very interesting concept, and to illustrate the role of what you say, the role of adversary, right? So we are basically here trying to understand the role of an adversary. So let me take one point. So I am again on the real line, right? Now suppose my point is this, right? And I'm talking about interval classifiers. Okay. So suppose the adversary comes and labels this as plus, right? Okay. So what would be your interval? So can you find an interval? So now the question is, can you find an interval which has this property that any point inside that interval is positive and all the points outside this are negative? So can you find an interval? So yes, if I do something like this, right, I have found a solution. Is it not? Okay. Now, if this point is the same point is labeled as negative by the adversary, then what happens? So I have to find any interval which does not contain this point. All right. Okay. So I found the solution when there is only one point. So it can shatter one point. Now suppose I have 2 points. So I'm just trying to give you some pointers so that you can work on it, right? So now I have 2 points, right? So now the adversary comes and labels these 2 points. Okay, and suppose the adversary is kind to you, and it comes and labels both the points as positive. Okay, so what would be the interval? Where would you draw the interval? Yes, so you should be able to answer this now. I mean, we have discussed this quite a bit. It should be in the interval. Whatever, I'm not worried about the length of the interval, nothing, right? Right now, I'm not worried about this because that's the problem at hand. I'm trying to solve it, right? And now I have this, and both the points are negative. All right. So now what happens? So my interval should be anything outside it, right? Either here or I can make it here, right? Both solutions are fine. Yeah. Okay. So are you getting this? So this is fine. Now suppose the adversary comes and labels one point as positive, one point as negative. So can I still find a solution, or can I still find an interval? Yes or no? Yeah, so I'll leave out the negative point, and I can do this, right? Now let me come here. So another labeling. So this is negative, this is positive, right? So I can again find a solution like this, right? So all 4 cases we have taken up. There is no other way an adversary can label these points. It can either label both of them positive, both of them negative. The left one is positive, right one negative, and the right one positive, and the left one negative. So these are the only 4 options the adversary has, right? And in all the cases, we have been able to find a solution, right? Now, similarly, you have to take 3 points. Okay, and then consider all the possible labelings and then figure out whether you can do this or not, whether you are able to find a solution for all the possible cases, 8 cases. Is that all right? So have you understood what you have to do? Okay. So similarly, then you have to come here. You have to talk about box classifiers, right? So you have to give me the maximum number for each one of them. You have to give me the maximum number of points which they can shatter. All right? Okay, so this is your exercise. Have you understood this? Okay, what you have to do? I've already talked about interval classifiers in some. I mean, I've given you 2 cases already. 1 point, it finds a solution. 2 points, it finds the solutions. Can it find a solution for 3 points? Can it find a solution for 4 points? And then so on, right? Okay. So, right. So, okay. So this I'll not do right now. So that's what I wanted to talk about in terms of adversary. So now let me take up another topic which I wanted to introduce, and that's on reinforcement learning. So let me just quickly search that. All right. So, okay. So the main concept in uh, reinforcement learning, right, is the trade-off between exploration and exploitation. We have already introduced this concept of exploration and exploitation earlier in the course in context of search, right? So you already know that what is exploration and what is exploitation. So exploitation is all about what you know already, right? So you exploit your knowledge about something to solve a particular problem, and exploration is more about trying to explore new options or new solutions, right? And I must have given you an example that suppose you want to go from here to Delhi, right? Okay, so your friends tell you that this is the best route, okay, and you do what, say you say that okay, but when you start off you say that okay, this is the best route I know, but my friends have told me, but I'll explore this new route which is looking quite good to me, right? So there is a diversion, right, 10 kilometers from Pilani, and I want to explore that. So you do exploration, right? So, and instead of going to your favorite restaurant all the time, you say that let me try out a new restaurant, okay, which has opened up in the neighborhood. So there is this concept of exploration and exploitation. So reinforcement learning allows you to mix the two, right? Okay, so that is what is reinforcement learning, and learning through interaction with the environment. So you interact with the environment, and then the environment responds, and then you again take an action, and so on. So this is basically the setting in reinforcement learning. And there are these concepts of state and action spaces. So I've already introduced these terms to you in some form, right? So how many states are possible, and from each state how many actions are possible, right? So if you are talking about a bot trying to explore an indoor environment, and there are tiles in that on the floor, and the bot has been designed that it can move either forward or backward or to the left or to the right. So there are only 4 actions, right? Okay, so like this. And if you compare it with the game of chess, then there are too many options. all right, because see, you can move any of the pieces that are there, which piece you move, and each of these pieces have a different way of moving. So the number of actions that you can perform from a given state are too many, right? Okay, and then we have this uh, 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 a process called as Markov decision process, and then there is something called a semi-Markov decision process. So I'll be introducing this Markov decision process, not today, but yeah, gradually. And the most famous reinforcement learning algorithm is about the Q learning algorithm. And there's another one which is also similar, which is called as the SARSA learning algorithm, right? Okay, so let me quickly introduce this. I have some 4-5 minutes. So RL is generally used to model Markov decision process and its variants. So what is MDP, right? So that is what we need to understand. So we will explore in a while. So let me, okay. So I'm introducing some concepts here, which are basically coming from the machine learning domain, but we would need them, I mean, not in depth, but we would just need them in some context, right? So very superficial things we need to understand. So the first concept is supervised learning, right? So what you are given is that you are given an input, and you are also told that for this input, this would be the output, okay? All right. So we say that you are given training data. So that means if I say that, say for each student registered in the course, so I have lots of things about you, right? So I have your ID number, I have your name, right? I know what is your major or the first degree, or what is your minor, right? What is your age, and which part of the country you come from, so state, and then so on, right? Okay, so I have many things about you, right? And I want to predict, right, say what grade you would get in this course. So the output is any one of A minus, B minus, C minus, D minus, and so on, right? Okay, so these are the labels. So you have a set of features, and then there is a corresponding label. So suppose this student that I'm talking about gets an A grade, right? Okay. All right, so you have this data, right, which we call as features, and then there is a corresponding label attached to it. All right, okay, and this label can be categorical, as you can see here, A minus, B minus, and then so on, or it could be a number, right? It could be a real number. Say, for example, rainfall, right? So rainfall would be say 13.5 millimeters of rain we received in a particular area. So whenever we have these numbers, right, we call these problems as regression problems. And if these are categorical labels, we call it classification problems, right? So this is what it is. So you are given some examples from which you can learn, right, and build models. All right. Whereas in unsupervised learning, we don't provide any kind of labels, right? So there is no training that is happening in this. So that's why it is called unsupervised. So you are only given the features. So I'm only given that these are the students that are there in my class, right, in a particular course. So what I want to do, I can do what, in this case, what kind of things I can do on this data. So I can find which X's or which students are similar, right? Okay. So what we do is we do some kind of, we run some kind of an algorithm called as clustering algorithms, right? So which give us, which forms, say, a few groups of students. So there are some students here, some students here, right? Some group of students, some groups of students here. So the characteristic, the main thing in this is that these X1s are more similar to each other than they are similar to X2 or X3, and same thing applies to other set of students, right, in X2 and X3. All right, so this we do. So these are two major things that we do as far as learning is concerned. Okay, but there's a third thing, right, which we call as reinforcement learning. So it is somewhere in between the two things, right? Okay, and so your training data is something like this. So what I'll do is I'll talk about this reinforcement learning in the next class, and then I'll give you a small assignment for the course on this concept, right? I may give it on MDP, or because MDP is very closely related to reinforcement learning, right? And or something on reinforcement learning, some task that you can actually complete using reinforcement learning. All right, so with that I'll stop, and if you have any questions, please feel free to ask.